Alright, so we're going to take a look at a system of three equations with three variables. And if you remember, my advice to you in solving these problems is that we're always trying to get it down to two variables, two equations. Okay? And in whatever way we could do that, we have to really think critically and look through the problem carefully and see if we notice anything that can help us through a problem like this. In this example, I actually set it up so that you look at the third equation and you see that the x is isolated. So I have x equaling 2y plus 3z, and if I look at the top equation, that's the only other equation with an x in it. So if I substitute into that top equation, I'm going to be left with a new equation with just y's and z's in it. And that will actually be helpful when I compare it to the second equation, because the second equation also only has y's and z's in it. So you could probably guess that after I simplify all of this, I'm going to go ahead and use elimination to solve this problem. So I took my top equation, I substituted, I'm going to combine my like terms, so that's going to give me 1y plus 5z equals -7, and then I have the equation underneath, which is y plus z equals 1, and then I have that bottom equation, which I really only use for substitution, which is x equals 2y plus 3z. Over here that's supposed to be 3z, right? Okay, so now I'm going to take my top two equations, and the reason I'm going to take those two equations is because I have two equations, two variables, and that is always the goal here. Two equations, two variables. Now, this is a standard elimination problem. So I have everything lined up. I'm going to multiply my bottom equation by -1. The top equation is going to remain the same. Bottom equation is going to become -y minus z equals -1. By the way, something that I should have done a lot earlier is write x equals, y equals, z equals over on the side as I'm solving. So add these equations together, I'll get 4z equals -8, z equals -2, and I can go ahead and fill that in. Z is -2. Looking at the two equations that I've been working with, if I go ahead and plug in z is -2, now I can solve for y. So y minus 10 equals -7, and y equals 3. So now I have y equals 3, I have z equals -2, and I'm going to actually go back to that third equation that I have not used in so long. X equals 2 times 3 plus 3 times -2. I'm going to get x equals 6 minus 6. I'm going to get x equals 0. So I have x equals 0, y equals 3, z equals -2, or I could write my solution as 0, 3, -2. Okay? So remember, the key to this problem was noticing that the x was by itself in the bottom equation, substituting, and then treating those two equations with two variables as a system and just using elimination there. Alright, we'll try another one. So this example is going to be a little different. This example is not going to utilize substitution. Instead, I'm going to have to use elimination with some of those equations with three variables. And what I'm going to notice is that I have a -y and a positive y with these two equations, but I also have a positive y and a -y with these two equations. So if I take the top two, x minus y plus z equals -1, and x plus y plus 3z equals -3, and add them together exactly as they are, I get 2x plus 4z equals -4 as a new equation. Let's say I go back and do the same thing with the bottom two. X plus y plus 3z equals -3, 2x minus y plus 2z equals 0. Add them together, I get 3x plus 5z equals -3. So now I have two equations with only x's and z's in them. So I'm going to focus on those two equations, forget everything else, and let's see if I can use elimination again to solve for x and z. And remember, x, y, z equals, that's when I know I'm done. Alright, so I'm going to multiply the top equation by 3, the bottom equation by negative 2. So 6x plus 12z equals negative 12. Negative 6x minus 10z equals positive 6. I get 2z equals negative 6. And I'll get z equals negative 3. So negative 3 goes up there. Okay, I'll take one of these equations. It actually doesn't matter if I go back to one of these or one of these. Okay, I'll take that top one there. So 6x minus 36 equals negative 12. 6x equals 24. X equals 4. Would have helped if I put the negative 3 in for the z. X is 4. Okay, and now I can go back to one of the original equations. I'll take the top one. So 4 minus y minus 3 equals negative 1. 1 minus y equals negative 1. Negative y equals negative 2. Y equals positive 2. So now I have 4, 2, negative 3. I believe that's my solution. I'm just going to go over here, just because that was that was tricky. I just want to check. 4 plus 2 is 6, minus 9 is negative 3. So that equation works. Okay? 8 minus 2 is 6, minus 6 is 0, so that equation works. That is indeed my solution, x, y, and z. I know that that solution is correct. So there really are not a list of steps with these problems. You really just need to look very carefully at the three equations that you're given and try to figure out, is there a way to get it down to two equations, each with two variables. That is always the goal. Once you get it to that point, it's standard substitution or elimination. So stick with it. Good luck with these problems.